How does the third generation Scarlett Solo compare to the Scarlett 2i2? And is it even any good? That's what we are going to find out in this video. Hey, Julian Kraus here, and here I have the Scarlett Solo in the third generation. So let's first check out the outside of the device and have a closer look at all the buttons and knobs. On the front of the third generation Scarlett Solo you will find one XLR microphone input with the corresponding gain knob right next to it. Below that you find two buttons. The left one is used to toggle the phantom power to the XLR input, and the right one engages the air mode. According to Focusrite, the air mode emulates the original Focusrite ISA preamps, and we will have a listen to how the air mode affects the sound later in the video. On the front you also get a TRS input with its own gain knob. This input can either be used as a line level input, or you can push the button and turn it into an instrument input where you can directly connect your electrical guitar to. On the far right, the Solo has a 1/4-inch headphone jack, and above it a button that lets you toggle the direct monitoring. And you also have a big knob which controls the outputs on the back and the volume of the headphone jack simultaneously. While testing, I noticed that contrary to my expectations, the outputs on the back are not muted when you plug in a pair of headphones. I think this is a bit weird because that means that when you have active monitors and a pair of headphones connected, you will hear the audio of both of them simultaneously. In my opinion, the outputs on the back should be muted once you plug in a pair of headphones, because when you do, you only want to listen to your headphones and not additionally the monitors. So far, I don't have any solution for this. Hopefully this can be addressed with a firmware update. And these are the outputs I'm talking about. There are two 1/4-inch balanced TRS outputs. On the back of the interface you also got a Kensington connector and the USB Type-C connector. Like I said in my Scarlett 2i2 review, I'm personally a big fan of the USB Type-C connector, and I like that Focusrite uses it in the newest generation. A few things to note though, this is not a USB 3.0 interface. Even though it uses a USB-C connector, it's a simple USB 2.0 connection. For audio interfaces, that's pretty much all that's needed. And the Solo comes with a Type-C to Type-A cable, so you don't have to have a USB Type-C connector on your PC or laptop. The Solo is quite a bit smaller than the 2i2 and pretty light. I would consider this to be a big benefit if you want to take this interface on the road with you. Even though it's very light, the red housing is still made out of aluminum, which gives the Solo a pretty rugged construction. All the knobs turn smoothly, yet still feel solid. So the construction of the Solo is pretty good. That's it for the outside. Let's see how the third generation Solo performs in terms of audio quality. Like its bigger brother, the Scarlett Solo has a maximum sample rate of 192 kHz. With such a high sample rate, the interface should be able to capture frequencies even above 20 kHz, which is considered to be the upper limit of human hearing. And you can see that in my frequency response measurement. The frequency response is very flat, with the -3 dB point at 75 kHz. And even at very low frequencies, the response has next to no roll-off. While testing, I noticed that the frequency response gets a bit worse when the gain is set to the maximum. Here you can see the same measurement again, but the gain on the Solo is turned up all the way. Here the low and high frequencies roll off quite a bit more, but I would still say that this is an acceptable performance, as in the audible range from 20 to 20 kHz, the response is still relatively flat. The Scarlett Solo Gen 3 also uses a 24-bit analog to digital converter, which means that it can theoretically record a very high dynamic range. Dynamic range is the difference between the strongest signal an interface can capture and its noise floor, and generally speaking you want this to be as big as possible. The dynamic range of the microphone input on the Solo is spec'd at 111 dBA weighted. I measured the dynamic range of my particular unit and it was very close to that with 110.6 dBA. That's a very high amount of dynamic range, and this means that you can leave yourself quite a bit of headroom while recording and amplify your recording in post without introducing any additional noise. So the dynamic range performance of the Scarlett Solo 3rd generation is great. Let's check out the preamp performance of the Solo. The equivalent input noise is a measurement of preamp noise, and it lets you directly compare the noise of different preamps. The Scarlett Solo is specified to have an equivalent input noise of -128 dBu A-weighted. My particular unit is a bit of an overachiever, coming in at an EIN of -129.2 dBu. This classifies as ultra low noise, and it is nice to see that the Solo performs on par with the 2i2, or in this case is even better. And here you can see some more interfaces and how their preamp performance is compared to the Scarlett Solo. The Solo sits right at the top with the top performers. And this is how the noise of some of these interfaces compare audibly. All recordings have been amplified in post so that you can clearly hear the noise, but other than that, there was no additional processing done. This wouldn't be a proper noise test without the Shure SM7B connected directly to the interface. This mic is pretty much a worst case scenario for preamps, as it has a very low sensitivity. And because of that, you have to use a lot of gain, and this brings out the noise of the preamp. Here is the practical noise floor of this recording setup. Have a listen. And before somebody asks in the comments, no, you don't need a Cloudlifter or FetHead with the Scarlett Solo. With the ultra low noise preamps in the Solo, there's only a minuscule difference, if any, in the noise floor when using an additional inline preamp. The preamp in the Scarlett Solo is simply good enough. As promised in the beginning of the video, I'm going to turn on the air mode now and let you hear what this sounds like. Now I activated the air mode, and this is how I sound like. As I described in my Focusrite 2i2 review, the air mode changes the frequency response of the mic input, and that's what you can see here. Compared to the flat frequency response with the air mode turned off, there is a slight rise towards 1 kHz, and then it rises to nearly 4 decibels towards 10,000 Hz. And this is what gives the audio a brighter, or as some would say, airier sound. And the air mode also adds a minute amount of distortion, but this is pretty much negligible because it is incredibly low. I just wanted to mention it for the sake of completeness. So, like in the Scarlett 2i2, the air mode on the Solo lets you accentuate high frequencies with the push of a button, which results in an airy sound. Depending on your recording scenario, this might be useful to you. One more thing I always test is the maximum system gain. If this is too low, you're not able to amplify low sensitive dynamic mics sufficiently. The Scarlett Solo Gen 3 has a maximum system gain of around 47 dBFS at 0 dBu, and this is a decent value. This means that with a mic like the SM7B, you most likely have to max out the gain, but this way you get a healthy audio level in your recording software, and that's totally fine. To make sure that the frequency response of a connected microphone is not influenced negatively, I checked the input impedance. The 2 kΩ of the mic input of the Solo is arguably a bit lower than the impedance of other interfaces, but it's still sufficient, so no problems here. The round-trip latency is the time it takes for an audio interface to put out a signal and then record it again. This is a combined measurement of the input and output latency, and you want this time to be as low as possible to not perceive any delay when monitoring audio from your DAW. These are the times I got with the 3rd generation Scarlett Solo, set to a sample rate of 48 kHz with different buffer sizes. And here are the latencies with 192 kHz sample rate. I have to stress that the RTL heavily depends on the used buffer size and sample rate. Which sample rate and buffer size you end up using depends on your current project and your PC. So take these numbers more as a rough guideline to what's able to achieve with the Scarlett Solo. Okay, enough about the recording quality of the Scarlett Solo. Let's take a look at the headphone output sound quality. The headphone amp in the Solo delivers a decent amount of power. More demanding headphones like the Sennheiser HD6XX probably don't get crazy loud, but they are fine for moderate listening levels. The frequency response of the output is pretty flat, and to ensure that it stays flat even with headphones connected, the output impedance is very low. That's nice to see and like it should be. One thing I'm very surprised by though is the high amount of distortion the Solo produces with low impedance headphones connected. In my test with a 32 ohm load, when I turned the gain from about 25 to 60%, the total harmonic distortion increased significantly, hitting nearly 0.5%. At this point, the distortion is plainly audible, and I think that's a big oversight by Focusrite, because many studio headphones these days seem to have a relatively low impedance. So it's a real pity that the Solo produces an audible amount of distortion with these types of headphones connected. With higher impedance headphones like 150 ohms, the performance was already significantly better, and here the distortion was pretty much negligible. But more detail on that in an upcoming video, where I compare many different headphone amps on a variety of audio interfaces. So subscribe if you don't want to miss it. Overall, the headphone output is okay, especially if you use higher impedance headphones, but don't expect any miracles from the Solo when you use low impedance headphones. So what's my verdict? I think the audio recording capabilities of the Solo are very good. It offers a pretty flat frequency response, the mic preamp is ultra low noise, and the amount of dynamic range the interface provides is also very high. Additionally, the air mode can give you a quick high frequency boost, which might be handy for some people. The headphone output, on the other hand, only delivers a mediocre performance. Low impedance headphones in combination with higher volume levels will result in an audible amount of distortion, so you're better off using high impedance headphones with the Solo. The Solo is essentially a smaller version of the third generation 2i2 with fewer input options and simpler monitoring controls. If you're okay with the quality of the headphone output with the third generation Solo, you will get a handy little interface which can record great sounding audio. And of course, the audio for this whole video has been recorded with the Solo, so you can get a feeling of how the Solo sounds like. Okay, that's it for now. Please give me a thumbs up and subscribe for more videos like this. I will see you all in the next one.